Hello everyone and welcome to MJ's Maths and Stats. That's MJ Magic Studio to you. I'm Mohit Jain, your host, your dost, and yes, today in ghost mode with Algebra of Irrational Numbers. Basically, today we'll talk about surds and indices, basics of indices, and what do we mean by that. When I say a to the power x is equals to n, that means n is the number or the continuous product of a taken x times. What is a to the power x? A to the power x is actually continued product of a taken how many times? X times. You can also see it here. If x continued product is taken a times, it is x to the power a. So a continued product taken x time is a to the power x. Now what is a and what is x here? A can be any number, but we call it base, and x in a normal language we call it power, but actually it is exponent. So a base to the power or exponent is equals to our number. That is the basic presentation of a continued product of a base. Now, one thing we need to be very clear with this, that the value of a should not be equals to 0 or 1 or plus minus infinity. Why? Because 0 to the power anything will give us 0. So there is no knowledge about what would be the value of x. Similarly, 1 to the power anything will also give us 1 back. That's why we cannot have a knowledge about x here, and similar thing is related to plus minus infinity also. Okay, now few presentation of surds to indices format or index or exponent format. Root x is x to the power half, square root or root x. Similarly, nth root of x is written as x to the power 1 by n. Now, why I pick up these two as an example? Because these two are something where I've seen many of us incurring mistakes. No need to laugh or smile because I've seen people making mistakes on this thing. X into x into x multiplied a times. I've seen people writing this as a into x. This is not a into x. It is x to the power a. We are multiplying. When we are multiplying the same base a number of times, that a will move up to the place of exponent. When we add up x plus x plus x a times, then it is equals to ax. Apple plus apple plus apple is 3 apples. So apple plus apple plus apple added up a times will give us a apples. Isn't it? It is not equals to a to the power x. It is not equals to x to the power a. It is just a into x. Basic things which we should know. 3 into 3 into 3 into 3 multiplied 4 times, it is 3 to the power 4 and not 4 into 3. 4 into 3 is 3 plus 3 plus 3 plus 3. Few bases of indices which we would be requiring while solving questions. X to the power 0 is 1. Any number to the power 0 is always equals to 1. X to the power minus a, if we have negative index, it would be 1 upon x to the power a. x to the power a into x to the power b, when we are multiplying the same bases but with different index, what will happen? Index or the exponent will get added up. It would be x to the power a plus b. And here if I use a equals to 0 and b equals to 1, let's see what we'll get. We'll get x to the power 0 into x to the power 1 is equals to x to the power 0 plus 1, that is 1. That means x to the power 0 is x to the power 1 by x to the power 1, that is x by x, which is equals to 1, and hence x to the power 0 is 1. Isn't it? Good. Now, when we are dividing x to the power a by x to the power b, bases are same but powers are different. When case of dividing, power gets subtracted. X to the power a by x to the power b is x to the power a minus b. Okay. Now, again, the 2 points where I have seen many people doing errors. X to the power a whole to the power b is not equals to x to the power a plus b. It might be equals to x to the power a plus b when a and b are like 2. Then you might end up getting this is x to the power a plus b, but not for all. This is actually equals to x to the power a b, not even a to the power b. It is not also x to the power a to the power b. It's different. It might be equals to this when a is equals to 1, b is equals to 1, or a is equals to b is equals to 2. You might end up getting this thing like x to the power a to the power b might be equals to x to the power a to the power b only when a is equals to b equals to 1. In that case, x will be equals to x, or a is equals to b is equals to 2. Then 2 into 2 is 4. 2 to the power 2 is also 4, but not for all values of a. Why? Because this is wrong notation. Correct notation is x to the power a to the power b is x to the power a into b. Similarly, x by y whole to the power a can also be written as x to the power a upon y to the power a. Okay, so please make note of this particular aspect. Now, 2 important bases of indices, which you may also call it cheat codes or tricks, or it's simply the concept which we should know. First, if a to the power m is equals to a to the power n, we can see that here bases are same, then this we can conclude that m is equals to n, but a should not be equals to 0 or plus minus 1 or plus minus infinity. 3 to the power m is equals to 3 to the power 4. We can conclude that m is equals to 4. Isn't it? Yes, we can. Okay, let's see the next one. If a to the power m is equals to b to the power m, here exponents are same, bases are different. Bases are different, b1, b2, but exponent is same. Okay, then we can conclude 3 different things. First, we need to be very sure that the exponent is not equals to 0. Because if exponent is equals to 0, it will, in both the cases, will make the value 1, and then we can't conclude anything about b1 and b2. So when exponent is not equals to 0, we can have 2 offerings from this particular equation. First is both the base would be equal when e is odd. If I say a cube is equals to b cube, I can very easily say a is equals to b. A to the power 5 is equals to b to the power 5. I can say a is equals to b. Okay, and number 2, b1 will be equals to plus minus b2 if e is even. If I say a square is equals to b square, it might happen that A is equals to B or minus B also, because on squaring both sides, both will give me the positive value. So make note of this and use it accordingly. Okay, next point in basis of algebra of irrational number surds is conjugate surds. Surds of the form a plus root b or a minus root b are said to be conjugate of each other. This is just an example. We can have different types of conjugates with different powers. It's just an example for the power 2. Like we know that a square minus b square is a plus b into a minus b. So if instead of these rational numbers a, b or a plus b, a minus b, it is given a plus root b, then we would be able to transfer this into rational format only when I am multiplying this by a minus root b. So it will become what? A square minus root b whole square. It will become a square minus b. So sum and product of two conjugate surds in this case is a rational number. What would be the sum in this case? Sum would be a plus root b into a minus root b, that would be 2a, and product would be a square minus b. So just a small example for degree 2, that if you get some root or if you get a surd in the form of a plus root b, its conjugate is a minus root b. And sum is always equals to twice a. Product is a square minus b. Rationalization factor. We have talked about conjugate root. Those conjugate surds are actually helping us out in rationalizing. Now what we mean by rationalizing factor? Two irrational numbers are said to be rationalizing factor of each other, one another, if their product is rational. Okay, now exercise time, and let's take up few special surds. I have handpicked few types for you to discuss in this basic video, and for the advanced types we will take up in other sessions on advanced algebra. So please pause the video and try to solve. I'll come back. Yes, I know you must have tried. Actually, we need to find the value of this. Let me do this with very basic format. Let x equals to root 30 plus root 30 plus root 30, and it's moving till infinity. So if I square both sides, what I'll get is x square equals 30 plus, again I'll have 30 plus root 30 plus root 30 and moving till infinity. Now can I say this is x square equals to 30 plus x, or x square minus x minus 30 is equals to 0. We can do middle term factorization, and what we'll get is x minus 6 into x plus 5 is equals to 0. X is equals to 6 or x is equals to minus 5. Since it is positive and it's moving on, I'll select the positive value. So x is equals to 6. Here the value of this surd is equals to 6, isn't it? Okay, let's quickly solve the second one also. Let the second one is equals to y. Then again I'll follow the same drill to solve this. Y square is 20 minus root over 20 minus root 20 minus root 20 and on. Again this can be written as y square equals 20 minus y, because this entire thing is moving to infinity, it is assumed to be y. Y square plus y minus 20 is 0. With middle term factorization, we'll get y plus 5 into y minus 4 equals to 0, or y is equals to 4, y is equals to minus 5. Since again it is like it will give us a positive value, I'm selecting y equals to 4. So this was the basic format which we know that we can follow to find or evaluate these kind of surds which are tending towards infinity. But I know you must be more keen on, do we really need to do these things in these kind of problems? No. These are spatial surds and I have grouped them into type 1. Now why they are spatial? We need to look at the number. They are spatial because these are of oblong number format. Now what are oblong number? If a number is written as product of two consecutive natural numbers, then that particular number is known as oblong number. You can see here 30 is equals to 5 into 6. You can see here 20 is equals to 4 into 5. That means these are oblong numbers. And whenever you have a spatial surds given to you like this, in this format, where the number k is in oblong number format, your answer is either n plus 1 or n, depending upon the sign given in the question. If plus sign is given, your answer is n plus 1 straight away, and if minus sign is there, your answer is n straight away. What you need to just identify is whether this k is in oblong number format or not. It will be in oblong number format only when it is product of two consecutive natural numbers. Here 30 is 5 into 6 and a plus sign is there. I'll suggest 6 and straight away I'll write answer 6. 20 is 4 into 5 is an oblong number format, and I can see minus sign here in this particular question. I'll select the lower one, that is 4, and I'll write answer straight away 4. Okay, now spatial surds type 2. Let this be x and we need to find the value of x. Now we have seen in type 1 that whenever k is there, we shall try to break it into n plus 1. 5 cannot be written as product of two consecutive natural number. That means this doesn't fall in type 1, our oblong number format. So let me use the basic method. Let me square this on both sides. X square is 5 plus x. Let me write this directly now. Now we know the drill that this particular thing will become x. So if I solve this, x square minus x minus 5 is 0. It's not possible for me to do middle term factorization. So let me use the basics of quadratic equation. And what are the basics? That if ax square plus bx plus c is equals to 0, then x equals minus b plus minus root over b square minus 4ac by 2a, where a, b, c are coefficients of x square, x and x to the power 0 respectively. So in this case, we have a 1, b equals to minus 1, c equals to minus 5. So x would be equals to 1 plus minus root over 1, b square minus 1 square is minus 1. Square is 1 actually. So minus 4 into a into minus 5 is plus 20 by 2a, 2 into 1 is 2. So it would be 1 plus minus root over 21 by 2. And since it is moving ahead, it should give me positive value. So let me select root 21 plus 1 by 2. So here the value of x would be root 21 plus 1 by 2. As simple as that. With use of quadratic equations, Sridharacharya method, direct formula, and we can do it. Similarly, we can do the second one also. So let me have the value for y also quickly. So if I square that on both sides, y square would be 7 minus y. Y square plus y minus 7 is 0. Using this Sridharacharya method, I can find the value of y directly. Y would be minus 1 plus minus root over b square is 1, minus 4 into 1 into minus 7 divided by 2a. So that would be minus 1 plus minus 28 plus 1, 29 by 2. I'll select the positive sign. So y would be root 29 minus 1 by 2. Yes, we can use this process and find the answer. But really we are going to use it in exams? Can we save our 5 seconds or maybe like 10 seconds in exam by using something where we can get these answers directly? Do we have something like that? If our surds is in the form k plus minus root over k plus minus root over k plus minus moving till infinity, we know the drill number 1, that is type 1. But and if k cannot be written in the form of n into n plus 1, then what is the value of k? Okay, then what is the value of this surd? Let it be s. Then s will be simply equals to root over 4k plus 1 plus minus 1 by 2. You know what? That's it. Now you will say how to select plus and minus. It depends upon these plus and minus. If it is always addition, I'll select addition sign. If it is minus minus minus, I'll select minus sign. Yes, now what we have in type 3. It looks like type 2, but it isn't. Okay, here in the middle there is no sign connecting. It's just format k, root k and moving towards infinity. If I take this as x and a square on both sides, we'll have x square equals to k into again root k moving towards infinity. So it can be written as x square equals to k into x. If I cancel out this x on both ends, x is equals to k. That's it. And now on the second thought, why we are supposed to calculate this even? Root 8 moving towards infinity. It is simply 8. This looks like surd of type 3, isn't it? Root 5 till infinity. So straight away answer to this is 5. Now this is 125 to the power x minus 1. If I need to make these bases same, then only I can compare the indices. We know that. So 125 is 5 cube. I can write this as 5 cube to the power x minus 1. Going back to the basics, x to the power a whole to the power b is x to the power a into b. So this should be 5 to the power 3 into x minus 1. Now if I comparing these two, here bases are same. If bases are same, power which is not equals to 0 can be compared, isn't it? So 1 would be equals to 3 into x minus 1. That is 3x minus 3. So 3x is equals to 1 plus 3, that is 4. Value of x is 4 by 3. So let's try one more. The question is there. If x plus 1 by x is equals to minus 3, find the value of this particular surd. I can see that it is of type 3. And it's moving in till infinity. So answer to this particular surd is nothing but x square plus 1 by x square. That's it. Now I know one more thing, that if x plus 1 by x is equals to k, then if I square this on both sides, I'll get x square plus 1 by x square plus 2 into x into 1 by x, that is equals to k square. If I cancel out, we'll get x square plus 1 by x square is k square minus 2. Now we should be knowing that is a formula, that if x plus 1 by x is equals to k, then straight away x square plus 1 by x square is k square minus 2. So if my x plus 1 by x is minus 3, x square plus 1 by x square would be minus 3 whole square minus 2. 9 minus 2 is 7. Straight away answer is 7. So spatial surds type 4. Have a look. Root 5, root 5, root 5, root 5, root 17, root 17, root 17. How this is different from type 3? Yes, type 3, we have this r root k, root k, root k multiplied, continuous multiplied. It was moving till infinity. But in this case, these terms are not moving till infinity. Process of multiplication is up to t terms only. Okay, let t be the number of times this number is there in this particular surd. 5, 5, 5, 5, I can say t is equals to 4 here. 17, 17, 17 given 3 times t is equals to 3. Then how to calculate these kind of surds in no time? A very simple process you need to follow. Just calculate 2 to the power t. That's it. Just calculate 2 to the power t. Let me show you what should be the answer to the first one now. So in this case, 2 to the power 4 is equals to 16. Done. Thus, answer to the first one is 5 to the power 16. And above that 16, just write 16 minus 1. That is the answer. Let me give you in basic k format. If it is k, 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 k and not tending towards infinity but till t terms only, answer would be k to the power 2 to the power t minus 1 upon 2 to the power t. It look a bit complicated, isn't it? So this is the basic process which we should follow. Similarly, for the second one, what is 2 to the power 3? 2 to the power 3 is 8 and hence answer would be 17 to the power 8 upon 8, just write 8 minus 1, that is 7. So final answer becomes 17 to the power of 7 by 8. If 1.001 and here is also 1.001, here is also 1.001, I have a to the power 1259 value is given. I have a to the power 2062 value is given. And the question asks is find the value of a to the power 3321. Okay, 1259 plus 2062 is giving me 3321, isn't it? So this can be written as a to the power 1259 into a to the power 2062. So that would be 3.52 into 7.85. That would be 27.632 or 27.63 or 64, depend upon the option given. And if it is a theta format type question, I'll prefer writing 27.632. So next popular question, yes, you have got it correct. This is type 1 or type 2? Type 1? Does it look like type 1? 12. If k is equals to 12, 12 is 3 into 4. Okay, this is type 1 oblong number format. We have a plus sign. Plus sign means bigger value need to be selected. Answer 4 straight away. A very popular question is there on your screen and you know the drill. Do try it yourself. I believe that you must have tried it. Find the sum of the expression. Now, when we see irrational surds in the denominator, our first basic intention is let's start with rationalizing and try to eliminate surd from the denominator, isn't it? So the rationalizing factor for the first one would be root 2 minus 1. So I'll write root 2 minus 1 in the numerator. When I multiply this with the denominator, it is root 2 plus 1 into root 2 minus 1. That will give me 2 minus 1, that is 1. Again, for the second one, rationalizing factor would be root 3 minus root 2. Here 3 square, root 3 square minus root 2 square is 3 minus 2, that is 1. Again, root 4 minus root 3. In the denominator we'll have 1, and for the last one it would be root 81 minus root 80, and 81 minus 80 will give me 1. So I just need to add them up, isn't it? Okay, so here I can see root 2 get cancelled with root 2. Again, the root 3 is getting cancelled with root 3. Root 4 will cancel out with root 4 here. And similarly, in the last one, which of the factor would be cancelled out? Root 81 or root 80? Obviously, root 80. In this root 4 minus root 3, what we cancel out first was root 3 and not root 4. Root 4 gets cancelled out with the next factor, isn't it? So here root 80 will get cancelled out with the previous factor. So we'll end up getting what? Minus 1. And from here we'll get plus root 81. That is 9 minus 1 is 8. Answer. Doesn't it look like a lengthy process? Isn't it? But that's the basics. And this is how things to be done. But yes, we can use some trick here, and we can only learn these tricks once we have solved these basics, isn't it? When we know the basics, we know that how tricks are gonna work. Let's see. If difference is 1, here difference is 1, here difference is 1, here difference is 1. Number 1, check. Number 2, now it is moving in this fashion. Root 1 plus root 2, then 2, 3, 3, 4, 4, 5, 5, 6, root 80 till root 81. Fine. Answer is straight away if I have root 1 plus root 2 plus 1 upon root 2 plus root 3 till whatever, root n plus 1. Answer is simply root over n plus 1 minus root 1. If instead of root 1, if I would have started with a, maybe like 1 upon root a plus root over a plus 1 plus 1 upon root over a plus 1 plus root over a plus 2, and the last term is like again root n plus root over n plus 1. Answer would be simply root over n plus 1 minus root a. That's a simple trick which we can use. But okay, one more basic questions related to indices. What's there? Q to the power minus a is 1 by r. R to the power minus b is 1 by s. And s to the power minus c is 1 by q. So what should be the value of a, b, c? S to the power minus c is there. Here it is 1 by s. So 1 by s is nothing but s to the power minus 1. Let me raise both sides to the power of c. So I'll have r to the power minus b into c is equals to s to the power minus c. Great. Now again I have r here, which is r to the power minus 1. So if I raise this to the power of b into c, what I'll have is q to the power of minus abc equals r to the power of minus bc, which should be equals to s to the power of minus c, which should be equals to 1 by q. 1 by q is nothing but q to the power of minus 1. So what I have, q to the power of minus abc equals q to the power of minus 1. abc is equals to 1. So what we have, let f is equals to x to the power n into y to the power m, which is equals to p. If x is doubled, so now our new f would be 2x to the power n, and y is halved. Y would be y by 2 to the power m. What is the new value of f? Okay, this is what they have asked. We need to find f dash in terms of p. Okay, so this is 2 to the power n into x to the power n into y to the power m by 2 to the power m. So can I write this as 2 to the power n minus m into x to the power n into y to the power m, that is nothing but p itself. So final answer would be 2 to the power n minus m into P. Yes, I believe that you must have solved this by now. Yes, so let's see what the answer would be. These type of questions which are tending towards infinity try to identify or locate the position where the particular fraction is repeating itself, isn't it? If I say this is x, so x is 1 upon 2 plus, where I can see 1 upon 2 plus again. Here I can see 1 upon 2 plus. Again it would be 1 upon 3 plus. Again that is 1 upon 3 plus. That means in this particular example, this point onward we are getting back our x again, isn't it? So x would be equals to 1 upon 2 plus 1 upon 3 plus x. Bingo, that's it. We just now need to solve this for x and that would be the answer, isn't it? So let's do it quickly now. So that would be 3 plus x. I'm multiplying numerator denominator by 3 plus x. 3 plus x upon 2 into 3 plus x would be 6 plus 2x plus 1. That is 3 plus x upon 2x plus 7. Yes, now this is equals to x. So 2x is square plus 7x equals 3 plus x. 2x square plus 6x minus 3 is 0, and the best way out is to use Sridharacharya method and to find the value of x. Here a is equals to 2, b is 6, c is minus 3, so my x would be minus b plus minus root over b square minus 4ac by 2a. 2a is 2 into 2, that is 4. So it should be minus 6 plus minus 36 plus 4 to 8 into 3 is 24 by 4. That would be minus 6 plus minus root over 60 by 4. I can take common 2 out from here. Here I can have 2 out from 60. 60 is 4 into 15. So final answer is, if I avoid the minus sign because it's positive, it must be giving me a positive answer, isn't it? It should be root 15 minus 3 by 2. The simplest of the question from all in one concept is there, where we should use numbers and solve it. Now, where to use these numbers? P into Q into R is given as 1 and nothing else is given about what can be the value of P, Q or R. So what should be our smart choice? P equals to Q equals to R equals to 1, isn't it? That should be the smart choice. P into Q into R will give us 1, and just substitute this value in the expression which value we need to evaluate. It should be 1 upon 1 plus 1 plus 1 inverse is 1 again, plus 1 upon 1 plus 1 plus 1 inverse is 1 again, 1 plus 1 plus 1 inverse is 1 again. That would be 1 by 3 plus 1 by 3 plus 1 by 3 and 1. Bingo. This is how this should be done. So one more example before we end up this basic concepts on algebra of irrational number. That's on your screen. Pause the video, try to solve. And I know you must have done that. You have answer by now. Yes, let's see what should be the answer. Okay, it doesn't look like any of the special surds, but when I look here, I can see something very similar to what we have done, isn't it? It is simply root 42 plus root 42 plus root 42, and it is moving towards infinity. This is our k. Can we write in this form n into n plus 1? Yes, this is 6 into 7. Bingo. Plus sign is also there. That means the value of this entire surd, it is surd of type 1, isn't it? Type 1, which what we did before. So this value should be 7. So my entire expression boiled down to root over 74 plus root over 700 into 7. And this is an easy thing to solve now. 74 plus 700 into 7, 4900. Root will give me what? 70. So this is root over 144. Root 144 is 12 again. I'll prefer to take up the positive values because it's all positive values are there in this expression. So answer is plus 12. Thank you everyone for participating. This was basics of surds and indices. I'll come back with the next video very soon where we will take up advanced questions on surds and indices and typical questions which have been asked in different competitive examination. But for that you need to stay connected with us. Thank you for being for so long in this video. Till the time, go through the basics, revise these questions. Your basics should be strong to do the advanced session. I'll bring up different shortcuts, different techniques, different cheat codes along with the basic contents, and we'll try to explore more on algebra of irrational numbers. Isn't it interesting? I'm Mohit Jain signing off from MJ's Maths and Stats. That's MJ Magic Studio to you. I'll see you soon. Thank you.